A very late morning to all of you. Hope all you are doing well, and good morning, good morning, good morning in the shop here. Getting warm again. Got the 1928 General Electric oscillating fan going here, keeping me kind of cool in the shop today. And a few days ago, I started work on the next project here, the next vintage restoration. The Sansui 1000A, which between 1966 and 1971 was a remarkable unit. It was a top-of-the-line Sansui, and what made it particularly special and what makes it the most complicated piece of vintage electronic gear that I own is the simple fact that it bridges the history between vacuum tube electronics, those nice glass tubes that you see glow red, and solid state using transistors. This unit has both in it, and it makes it very complicated to work on, because not only do you have to be a little versed in you have to be a lot of versed in vacuum tube technology and being able to work on things so you don't kill yourself. There's very high voltages running around in these units, 400 to 500 volts. But you also need to know a bit about solid state technology too, or using discrete components that do the same thing as vacuum tubes do, but using silicone. And I got the unit in here, and let's talk about a couple things before I show it to you. The first thing, as I stressed, is working on any electronic device is dangerous. And we have TV repairmen in the 1930s, 40s, well, the 1940s and 50s that would get electrocuted and things, and then you would have people that would get electrocuted trying to work on vintage audio gear using vacuum tubes, because the voltages pack a wallop. Okay, 450 volts DC, 500 volts DC is nothing to goof around. So you always want to be working with knowledge. Never want to have two hands in the device, or you complete a circuit across your chest and you could induce a terrific shock that could stop your heart. Okay, so this stuff is no joke. Okay, the other thing I want to stress when I discuss with you guys with what I found on this unit is the simple fact that when some people attempt to do repairs on electronic equipment, they tend to think that components failed, maybe electrolytic capacitors, vacuum tubes. I checked all the vacuum tubes on the unit. They're okay. Some of them are marginal, but they're okay. But the thing is, you want to always start with the most simple proposition first. I've had this unit for a few years. I think about 3 or 4 years ago, I put it on the power supply. I slowly increased the voltage enough to determine that nobody was home in the unit. It wasn't getting any power. Well, a lot of my it wasn't working. A lot of my units exhibit the same problem. Most of the stuff that comes into the shop just doesn't. Nobody's home. No lights, no glow of vacuum tubes, no nothing. And the thing is, you have to look at things from the simplest point of view first. And that's what I did today when I discovered a few problems with the unit and a few things that probably happened to the unit and resulted in some damage. Can it be fixed? Well, I always say if you can get the unit to power up and at least squeak or spark, or not spark but squawk or make noise, then you're already 3/4 of the way towards getting the unit into a restoration mode. I'm also very lucky. I don't even remember how I came upon this unit. It might have been a private sale. It might have been a thrift shop unit, but I was lucky that it has the original operating manual, the 1000A, made in Japan between 1965, 1966, and 1971. And it's nice inside of the manual, because it has the whole the whole electronic schematic here, or the pathway for power. And all this is doing is carrying around power at different voltages around the unit, and hitting components, slowing down the pathway, storing the energy for a minute, and then releasing it in the case of capacitors and things. But we don't want to go complicated. We want to go simple. And one of the other things that I've always contended in vintage electronic repairs is wherever you have mechanical interfaces, they will go bad before the electronic things go bad. Meaning, if you have a lack of power, your power switch probably failed from 5,000 times being clicked in and out and in and out. If the balance control doesn't work on the unit, it's probably because it started to get a little corrosion on the contacts and things. It's got nothing really to do with the major electronic components within the unit, but it has everything to do with switches, knobs, things of that nature that can wear out, lose contact. So let's come down and see what I discovered here. Chester, you can see it sitting back there in the box. Accurate testing of New York City. And I tested all the tubes, and they tested out, well, the big output tubes here, the detector tubes, everything tested out pretty well. I was talking about the early transistors. Look at these early, very early primitive ones down here. Very difficult to find and to replace. So you always hope that they're still okay. When I went up to power the unit, and let me, I have to tell you, this is also the heaviest AM/FM stereo amplifier receiver I've ever worked on. It weighs about 50 pounds. You can see the big chunky transformer and the two huge speaker output transformers over here. It's got a lot of bells and whistles on the front. You can drive different sets of speakers. I'm lucky it's in pretty good shape, the faceplate. The only negative, aesthetically speaking, is the lack of a knob that matches the rest of the set. But eventually I'll be able to acquire one of them. If you take a look at the bottom of the unit here, you can see it's inordinately complicated. Okay, but I'm not a part changer unless it absolutely need be. I'm one that works on the simple propositions first and then goes to the more complicated. Okay? Yes. Does it freak you out? Yes, it should freak you out. There's a lot going on in here, but basically you have to think of it this way. It's laying down five or six different tracks and subtracks for electricity flow, whether it's taking the signal in from a phono, a tape player, the tuner. There's just different pathways that are laid down in here, and a few main ones that overlap all of the sub pathways and things. Since I have it sitting upright here, let me get the light set up and we'll take a closer look. I always like to do a visual inspection first. And when I looked at the unit in here, I like to look at the control switches very closely. The AM, FM, selector, stereo, mono, balance, treble, bass. And I noticed that there was some separation in some of these. You can see that kind of move back and forth there. And that kind of concerned me because it made me think that the front end here got dropped on the ground and it caused that to sort of separate a little bit. I pushed another one. I had the same phenomena in another area too, and I managed to repair this. But this still has some flex in it, and the whole what they call the whole potentiometer, or the thing that moves back and forth, may have to be removed and tightened up externally there. So I was able to do the best I could. I didn't like, that thing was so widely separated. It was like a half an inch of separation, and it was affecting the volume control. And I think down here on the the heck was this? The base control was the same sort of phenomena going on. So obviously you can see the separation here compared to down here in the unit. So I've tried to get that back as best I can. As you can see, it's still a little bit squishy there. I'm not really crazy about it, but that was not really the main problem. I also took the opportunity to take the lubricants. Do not use WD-40, okay? It'll destroy your unit. You use something called electronic cleaner, and Deoxid is the name of a brand name of a good one. And you spray down the controls real well, and then you rock them back and forth to work them in a little bit. Okay, so I did all that today to ensure better contacts on these. Remember I was telling you about the mechanical interfaces in here? There's a lot of them in here, and these are the things that usually result in the most problems, besides maybe a bad vacuum tube. These are the things that cause the most problem in this particular area. But I found a problem that I had never encountered before, and it was probably one of the reasons that I picked this up cheap as a dead unit. Because people will sell things if it doesn't work because they think the worst, like something catastrophic happened on the inside of it. But that's not necessarily the case. Oh, by the way, some of my electronic repair buddies consider me the laziest electronic repair person in the business. It is probably true. The less I can do to get something going on, the better. I don't sit here and enjoy changing out 10,000 parts, being a part changer and hoping, I finally got to the one that did what I wanted to do at the beginning. We're of a higher intellectual order here. We have to think about the way that electricity flows. Okay, so if that makes me lazy, that makes me lazy. I'd rather work smart and be lazy than work hard and be kind of dumb, right? They're going to ask me about the fan, so I'll just show you guys the beautiful oscillating fan there, General Electric 1928. Boy, they don't make them like that anymore. That itself weighs about 25 pounds with the stand, and it's one of the earliest design oscillators there. It moves it back and forth. It's pretty cool, huh? Keeps me cool too. I was fiddling around, and this is always the repair person's best friend, is a multimeter, because you can check AC voltage, DC voltage, capacitance, just all kinds of things, diodes, all kinds of things. Checking around inside, of course, what comes into the unit is AC power. And I knew that the power was going into the unit here, but it seemed to stop and not flow through the unit, and I was kind of buffaloed. I kept doing a lot of work underneath, testing and probing carefully at different locations, until finally I got really frustrated, and I went to pull the fuse. Now, I did check the fuse initially when I brought it into the shop here. I did check the fuse initially when it came in, but I did not notice a problem that I was to notice later. And I don't know, because it got jiggled or dropped or whatever, but these fuse holders have a little spring in the back of them here. You can see that kind of bounce a little bit there. And that spring had over time become so depressed that it was not allowing the fuse to make end-to-end contact here. What a stupid simple problem, right? But that prevents the whole unit from powering on. It's also interesting, when I pulled the fuse, there was no blown fuse. It was still a good fuse, and that led me to believe that that nothing catastrophic had happened to the unit. But it's kind of unusual. Usually when one of these units blows up, the fuse will be one of the first things to go, but this fuse came out intact. So I got I got a little hook, dental pick with a little hook, and I pulled the end spring a little bit to bring it out towards the end a little bit, and lo and behold, that's what I got. That's one of the most beautiful sights that you can see in the repair business, is the glow of vacuum tubes in here, and they all seem to be okay. This one back here, I'm not going to get too detailed. This one might, this particular front one might have a problem, but I'm not going to worry about that now. But you can see it's lit up on the front. There's some problems with the stereo thing. Let me see if I can switch this to tuner here. That lights up, but the meter doesn't work. I mean, there's a lot of things to be overcome, but you're already more than 3/4 of the way. Already more than 3/4 of the way home. It's running, but it's rough. I'll let you hear it. Now, don't be shocked. I mean, it's crazy bad, but it's working, you know. I have a very primitive antenna on it. The stereo function works. I'm getting balance on both sides here, which is good. It's worth cheering about anyway. It's a start. So we got some work to do, but it's a great first start. Great first start. Not sure about the AM. Let's see, I don't know what AM broad.
Some new things that you need to know about. That's coming up this afternoon. We go and let's talk to Frank. Hey, yo, Frank. How you doing? I'm trying to locate.
We got fire on the hole in AM too. I'm just still getting used to the unit, to tell you the truth. But we are on our way. I don't have to worry about any copyright match, right?
And complain about having to mow the lawn again. Good news is, it's easy to make a home and auto through Progressive and save on your car.
We get nothing on the meter here. It's hard to see, but it's not moving.
Progressive Casualty. Progressive discount not available in all states.
That's going to be a wrap up today, guys. It's always a really thrilling moment in any workshop when something comes to life. I don't care if you're rebuilding an engine and the first time you set your timing and you put your plugs in and your top cylinder lubricant and you fire up and she goes. That's a pretty exciting time. It's equally exciting in the electronics world when you bring something back to life that hasn't had fire in the hole, maybe 1 decade, maybe 2 decades, who knows, okay? But the Sansui 1000A is a very valuable unit, going somewhere between $500 and $1,000 depending on condition. It's also one of the first units that was capable of throwing out 100 watts, which was huge 1965 to 1971. And it has that great distinction of being the bridge between vacuum tube technology and solid state. It's almost like Sansui didn't know which way things would go, so we'll put a little bit of each. We'll put 1 scoop of vanilla and 1 scoop of chocolate on top. Makes it a tough unit to work on. Again, I'm going to go through and do the easy stuff first and back out to some of the change out a few parts here and there. But that is for a future video. Okay, thanks so much for being along, guys. Thumbs up and comments are appreciated. Always enjoy the thumbs up, and glad to have you along in another vintage audio restoration journey. The Sansui 1000A, over 50 pounds.